Welcome to Food Technology 1, FOT150S. My name is Vosim Shaisa, and today I'm going to talk to you about the subject of the raw material and the process. This is a continuation of the video series that we have started, and this is the third video that we are looking at in terms of this topic that we are talking about. So, we've already covered the introduction, and the last video we were talking about the geometric properties of food materials, where we highlighted factors that affect that falls under the geometric properties includes uniformity of shape, freedom from surface irregularities, size and weight of food units, just to mention a few. Today we are going to look at the physical properties of these that affect process suitability in terms of the raw materials that we have. So, under physical properties, there are many properties which, in addition to the geometric properties, warrant consideration when selecting food raw materials. And under physical properties, these include things like the color of the food, the texture, the aero and the hydrodynamic properties or the hydrodynamic behavior, and the resistance to mechanical stress and frictional characteristics. So, all in all, there are 5 factors that we are going to look at under physical properties. So, let us investigate each factor. So, we're going to start with the color of the raw material. So much of the appeal of fruits and vegetables in our diets is due to their considerable color. And we know that consumers consume foods based on the appeal, and it's the color that attracts us to consume certain food products. So the processing of foods generally then alters the raw material color. It can either has a positive influence or a negative influence, which means it can either improve or decrease the intensity of the color. So that is the processing, right? So think of this, for example, if you are going to be baking a muffin. So you'll start with your dough. So once you bake it, then for example, if it's cappuccino, you'll start with a dough that is almost like golden brown. So when it comes out, it's nicely brown color, which is really appealing. So that is a positive aspect of the processing. So the baking is the processing. But let's say for some example, then you decide to go and visit your friend in Sako, and then you are baking at MGR. Then you leave your muffins in the baking oven. Then you go and stay there for an hour. When you come back, the muffins, they are completely burnt, so turning black, right? So that is an undesirable reaction that has happened. So when we look in the context of raw materials such as fruits and vegetables, so there's a general practice to add what we call chemicals that will intensify the color. Especially people add an alkali, which is to cauliflower, which is sodium bicarbonate. So this is not really an industrial practice, but it's a practice that is done normally at home. So in low temperature processing, choosing the raw material on the color factor is a relative reasonable index of suitability. So this we mean that for low temperature processes such as chilling, freezing, or freeze drying, the color changes are minimal during this processing. Thus, the color of the raw material is a good guide for suitability of processing to see if it is suitable for further processing. However, when we come to high temperature processing, the fresh food color is not a reliable index of suitability. Let me repeat that. Megan, we are saying In low temperature processing, choosing the raw material on the color factor is relatively a reasonable index of suitability. So it's saying if you are going to process using low temperatures, right? So you can choose your raw material based on the color. However, if you are going to use high temperature processing, so the color that you have of your fresh food is not a reliable index of suitability. And I'll go on to explain why on the next slide. Why is this so? Let's look at some example. This is because processes such as the canning, when you've got apples or pears, these they develop a pink tinge on canning. Whilst if you've got a product like a root, which is rhubarb, as you can see at the bottom, so and some cherries, cherry varieties, these they become bleached due to the migration of the color into the canning syrups. So for example, beetroot, which is boiled in water, is a good example. So you find out the water also turns now into it becomes red, it becomes dyed. So the question that you should ask as a student of food science and technology, one taught by Dr. Mshayisa, is what are the color pigments that are found in rhubarb? Rhubarb is this red. What color pigments are found there? See, there's something reddish there, there's something green. So that will explain to the bleaching. So look out for this question in the tutorials, or also maybe not in the exams, so but it's important to understand that heat processing especially can then alter the color of your raw materials. Right, just want to pause here. So we are saying apples and pears develop a pink tinge on canning, whilst rhubarb and some cherry varieties they become bleached due to the migration of the color into the canning syrup, which is things like beetroot. Right. Another important example that we can make is that of green vegetables, right, which turn brown green due to the chlorophyll. You remember we spoke about chlorophyll in the section of fruits and vegetables. We said under heat processing, this molecule or this color compound or color pigment, which is chlorophyll, it is converted to phytoin during heat processing. So that is why you find out your spinach is no longer green, bright green when you cook it, but it has turned to brown green. So this is as a result of the processing of the heat process that you expose your raw material to. So processing has influence on the color of the raw materials that you are using. If we look at potatoes, potatoes are an interesting case because with potatoes they pose special problems. For example, there are certain varieties which exhibit minimum browning, right? So certain potato varieties or types of potatoes which show minimum browning, these are used for canning and dehydration processes, right? Because you don't want a potato that is brown basically. And if a product is canned, sometimes we've got products that are canned in glass, so the appeal is very important, right? So in these cases they want varieties, a processor wants varieties that exhibit minimum browning. However, on the other side, if you are going to produce potato chips, you know, your Lay's, your smoked beef Simba chips, and also all these things. So browning reactions in these cases may be necessary. Right. So the question is for us as food science and technology professionals, how do we overcome these problems when we are dealing with raw materials? So the first thing we need to understand is that we need to select varieties of known performance under specific conditions. So whenever you have a raw material, you need to know how does it perform under specific processing conditions. If you are going to can the product, how does the variety, which is your raw material, your potato, how does it perform in canning? How does it perform if it's heated up to 100 degrees, 120 degrees? Are there any reactions? Is there any change in color? Right? So, and the application of the correct pre-treatment. So we need to apply the correct pre-treatment to your raw materials. Last week and also this week, we've done a practical on blanching. And you'll all agree with me that, for example, pears, right? When they are blanched for a longer period of time, they become then mushy and soft. You understand? So this is a result of the characteristics of the material, and blanching in this case, which is a pre-treatment, will definitely have an influence on the textural properties. We're going to cover textural properties next, but it will have an influence on the textural properties of your raw material. So we also use things like antioxidants. So antioxidants are things that prevent things like reactions that like lipid oxidation into food products. So we can also use pre-treatment of water that will come into contact with the raw material. So maybe Avuyila, you are asking the question, why do we have to pre-treat water? Ulani, the answer is that some of the water or some of the components, not all water is pure. So some of the water may contain impurities that will have negative influence in your food products. So we can also use processing conditions that retain or enhance natural colors. Right. So the use of colorants of natural origin or artificial origin within prescribed limits. So we can also add either natural or synthetic colorants. Remember when we covered the section on the fruits and vegetables on pigments, I mentioned that some of the raw materials or some of the color pigments are used as colorants. They extract those colorants, especially for example things like beetroot, things like carrots. Those will give us a reddish color, and the other one will give us an orange color, which can be applied in food processes in order to enhance the color of the process of the product. So in this case now we need to use these colorants with prescribed limits, within the prescribed limits. So it means you don't just use any amount that you want to use. So you can't just like, okay, let's use 10 kilograms. No, it should be within the prescribed limits. So the second thing that I would like us to talk about is the textural properties of the raw material. So the first requirement when it comes to texture is that the raw material, one, it must be sufficiently robust to withstand the mechanical stresses to which it is subjected during the preparation operations. So here I mean, for example, if you're going to have the raw material, so it must be able to withstand the mechanical stresses that is put through when you are sorting the material, when you are grading, and when you are washing this raw material, right? And then this second point is that the raw material must be able to withstand the processing conditions so as to yield a final product of the desired texture. We know that from the section that we've covered on the fruits and vegetables, we've also mentioned that there is things like loss of Tega. So cell disruption leads to loss of Tega pressure, and this will result in the softening of the tissues of your raw material, as that's what you see when you are blanching pears, is that, for example, they become mushy because the cell now is disrupted, you understand? So there is a loss of the Tega pressure. So the material must therefore be sufficiently robust to withstand mechanical handling, as I mentioned, sorting and grading, the washing operations. So it must also withstand processing to deliver a final product that is of the desired texture. So you want your material, one, to be sufficiently robust to withstand mechanical handling, two, to withstand the processing to deliver a final product of the desired texture. So we know there are these guys which have done horticulture here in class, and some of you will know that botanists are the people that work with plants. They have developed varieties that are capable to withstand these conditions of processing to facilitate, one, washing. So there are special peaches and tomatoes which are designed to facilitate washing, especially in terms of the removal of the stalk in black currants and in beans and pears again. Right, so these varieties are specially selected to withstand these properties. So I also want to highlight to you that if, for example, we are cooking food products, what can happen? Let's take, for example, meat. Cooking can make meat more or less tender than the original raw cut. So we know that when meat is cooked, there is a tenderizing influence there. What happens on a molecular level is that the fat melts and contributes to tenderness. And the collagen that we normally find in meat dissolves in hot liquids and become a soft gelatin. And therefore, what basically will then happen is that the muscle fibers that you find in meat, they will separate and the tissue will become more and more and more tender. So there are also two toughening influences that occurs in meat. So if you are overheating, can cause your muscle fibers to contract and the meat to shrink and become tougher. And therefore what will basically happen is that the moisture of your product will evaporate and the dry tissue becomes tougher. So texture plays a very important role in not only in the raw material but also in the final product that you as a food scientist, that you as a product developer must control and must be cautious in terms of how you handle your raw material or your food product. So perhaps you might be asking us, how do we then evaluate texture in food products? So one of the things that we've done or we do is that we can use a trained test panelist to determine the texture. So you call people to come and taste meat products, as you guys have done with the salami, the Russian. So some people say, no, it's tender, it's tough, it's chewy, and all those things. But we can also use, in addition to human beings, we can also use instrumental or instruments that are designed to measure texture. A plunger. So you put in a plunger into your apple, so it will tell you how firm your apple is, right? So the evaluation of textural characteristics is based either, one, on the sensory testing using trained panelists or on instrumental procedures. We have things like tenderometer or other machines that, for example, Brookfield viscometer, which can measure both the texture and the viscosity of the food products. So the other important thing to note is that under aero and hydrodynamic properties, aero refers to air and hydro refers to water. Right, so we can exploit the high aero and hydrodynamic properties of the raw materials in terms of handling them. It's because the differences of these properties are generally used, one, in the cleaning process, to sort and also to grade raw materials. We'll go deeper with these two unit operations, sorting and grading, in the coming chapters. Air and water are generally used for conveying materials, and thus these properties are very important. So if you want to move your materials from one place to another, you may use air or water. Right. So in addition to this, air and water are also used frequently to mix the materials, raw materials. So the manner in which these materials behave in fluid flow is greatly dependent on the physical characteristics of the material. So if we are looking to exploit the aero and the hydrodynamic properties of the raw materials, so you need to take factors such as the density of your material, the porosity, the crystal structure into consideration, and the surface properties which are greatly impacted by the fluid flow characteristics. Right. The next point that we need to look at is, which is the last one I think, is the frictional properties. So with regards to the frictional properties, when you have grain of any type, right, when you want to migrate it down, so moving it down a chute or is being discharged from a bulk bin, the static frictional forces between the particle and the wall must be overcome before the flow commences. Right. So this is a is kicking in your physics into play. Right. So once your material begins to flow, the coefficient or the dynamic friction must be exceeded in order for that material to continue to flow. That's basic physics, right? So to maintain the flow of the grain, the same static frictional forces must be exceeded. This principle can then be used to clean materials from contamination, since the contaminants, they differ in their static nature when in contact with certain materials. So this is similar to magnetic forces, which are used for magnetic removal or cleaning of ferrous materials from food products. I think is as simple as that. Right, so the next thing that we need to talk about is the functional properties. Functional properties. So the raw material of ideal functionality is one raw material that may be processed to give a high quality product whilst permitting maximum process effectiveness. And it's obviously that the functional properties required of a material will vary depending upon the process to which it will be subjected to. I will repeat this. The functional properties required of a material will vary depending on the processes to which the material is subjected to. Right. So under these functional properties, we are going to talk about flavor, resistance to processing stress, and freedom from defects. And these are very important in the food industry as a whole. So let's look at each factor. As I've said, the ideal material results in choice quality final products whilst allowing maximum process effectiveness. Over the years, breeders have come up with research which has developed varieties of specifically designed for process suitability. And these examples include things like chickens that are bred specifically to lay in eggs production, and also some properties of chickens that are only produced specifically for meat production. We also have sheep that is bred, or kind of, I think bred is the correct word. Bred for to produce wool, and some specifically for meat. Same with cattle. Then we also have wheat that is grown specifically to produce soft or hard flour for specific baking needs. So let us investigate each factor. Let's look at flavor as the first attribute or the first characteristics that we can look at under the functional properties. After we've done sensory evaluation, now it should be clear to you that consumers have differing flavor preferences, right? And I also think that perhaps more than any other property, flavor is a matter of personal preference. I agree deeply, because flavor is influenced by things like your age, how old are you, your gender, your culture, the location where you are, the religion, and many other factors, right? Therefore, how does this influence or affect us as as food processors or food scientists? So, in serving a processed product to a mass market, care should be taken to avoid extremes, too much salt, too much chili, right? So, as much as we can process foods for specific markets, we should remember that things like salt, yes, it can be added by the consumer, but it is not easily removed or masked during production. So this is a very important point to note, that even with sugar, right? So sugar can always be added at the other hand. And consumers, I can tell you by now, they are very quick to pick up any changes. So I was speaking to some people. They say to me, hey, the Sprite does not taste the same anymore. Unfortunately, I don't drink Sprite, those things that make people obese. But yeah, this is what the people were saying to me, that does not taste the same anymore. Then when I looked at the packaging, I found, oh, they have removed the fructose and replaced it with non-nutritive sweetener. So the degree of sweetness is still there, but it provides them with an aftertaste, right? So generally, foods are flavored by additives and is not completely reliant on the natural flavors. Not all foods that we consume contains natural flavors, so we can add in flavors into the food products. And we can also have raw materials that are selected in terms of retention of a characteristic flavor. You can choose which raw material you use to retain more flavor for you. Flavorants could be added to boost a particular sensation. So, more importantly is that flavor is of less importance than other factors, for example, than color and texture, in determining the suitability of a variety of processing. So this is not really that much. It does not rank highly over the flavor, other than color and texture. So let's look at now the resistance to processing stress. So to overcome some of the difficulties of processing, so it is important to develop adequate testing before approving raw materials for processing purposes. You will see this when you are doing your beverage or your ginger beer, is that you need to test again and again and again and again for you to be sure whether you can use this raw material for these particular processes that you have. And the resistance to processing stress, one of the examples that I can give you is that apples, they vary in suitability for processing. You find that apple varieties, some lose their rigidity upon processing and they are unsuitable. White flesh acid varieties are preferred for canning and freezing. Things like, we have things like the Granny Smith apples, right? So if we look at the peaches, the Clingstone variety is highly suited for canning, whilst the Freestone and more flavorful varieties, they disintegrate upon processing. So the variety that you choose for any process, it's very important to consider, what variety am I choosing? How does this variety behave when it's put under processing stress? Pears also, they vary well. You've got the tough marrow-fed pear, which is suited for canning, whilst the other tender varieties are used for freezing. Right. You also have the Bartlett's peas. These they develop a pink tinge upon processing. So the soil quality and the use of high pH fruit um, is a big problem that manufacturers to needs to deal with, and this is basically because of the tannin content of these varieties. So the growing conditions and the soil types are shown to be of importance in controlling this defect, and using high pH fruit could eliminate the pink tinge formation. So freedom from defects, think this is the last part. So raw materials cost is a major fraction of the manufacturing cost of processed foods. So as a manufacturer, it is important that you procure materials of low defects level to reduce any losses. So it's very important that when the manufacturers purchases raw materials, so you choose a low defect level in the process. Cleaning, sorting, and grading. These also incur labor and plant cost and may cause material damage, producing defects. So the choice of the cleaning method, how you sort, how you grade, can also cause damage to your material, especially in the case of fruits and vegetables. So this is prevented by careful plant design, and adequately trained staff is important to reduce process defects. So damage can occur during the sowing of insufficiently resistant varieties and by poor harvesting methods and handling. You've seen that cauliflower can also develop black spots. So the defects, so by the time it gets into your Pick n Pay or Woolworths, you don't want to see black spots in cauliflower. So if you see black spots, you know that is not a good quality product. So this is evident in the high waste that is generated in food processing plants, right? So because we are creative human beings, what processors then now do is that they offer wastage or yield bonuses. So for example, if on a monthly basis we produce less than 2 tons of waste, then the employees they get a bonus for that. So they've accumulated less waste from the product, from the process. So in conclusion, geometric factors that affect process suitability includes geometric deformities and inequalities, the mechanical damage due to impact, puncture, or abrasion, so the color defects, insect, animal, fungal, and microbial damage. And all these factors are what the food processor needs to control. Things like textural and functional defects, immaturity or over maturity of your products. So this brings us to the end of this today's video session, and next we're going to look at the mechanization and the raw material. So practice those tutorials that are uploaded for you on Blackboard in the meantime, and by probably next week we should have some online assessments or online tests or online tutorials set up for you. If you've got any questions or comments, drop me an email or just write a question on the WhatsApp group. I think other people will also be keen to contribute and participate. I already know that Sanele has some questions over there, and also we see that Weldrina also has some questions. Koopman, there's a lot of people who've got questions. So I think if you guys also utilize the WhatsApp platform so that we can engage all of us as food science and technology. Okay, thank you very much. Have a nice time.